Let's do a couple more examples of how to do a summation with an arithmetic sequence. Okay, here's an arithmetic sequence that starts at 60 and goes to 120, and each time the number increases by 4. So our common difference is 4. For our formula, we need n, we need a sub 1, and we need a sub n. A sub 1 is 60, a sub n is 120. So we have those two numbers to plug in. The problem is we need to know how many pairs there are. So that would require either counting by actually listing them out, or we could create a formula and then use the formula to figure out n for 120. So let's go ahead and make a general formula. We know that d is 4 because it's adding 4 each time. And we know that the first term of our sequence is 60. So what number would we need to add to this to have it start at 60? I think 56 would work, right? So there's our formula. So now if we want to find what n is, we plug in 120. Oh, and that should be a 4. And we solve for n this time instead. So I'm going to subtract 56. That gives me, is that 64? And then divide both sides by 4, so n would equal 16. I believe that's right. So now we have the other number for our formula. 16 divided by 2, that means there's 8 pairs of numbers. And the numbers, as we pair them up, will add up to 180. So then to get our sum, we just go 8 times 180. So I believe that would mean that the sum for this problem is 1,440. Okay, story problem. Suppose there is some artwork being created, and this artwork is made of tiles. The top row of the artwork contains 10 tiles. The bottom row of the artwork contains 20 tiles. There is one less tile in each row. How many tiles total will be needed for this art piece? Okay, well we know that the top row has 10, so that can be a sub 1 if we wanted it to be. We know that the bottom row has 20, so that could be a sub 2, not 2, but n, sorry, the last number. A sub 1, a sub n, so then the only problem again is that we need to find n. Some of you might be quick to say, well it's just going up 1 each time, so that means that there's 10 rows, n equals 10, because we're going from 10 to 20. Be cautious though, because there's actually 11 rows. Don't believe me? Let's do it using the same method we did in the last problem. So a sub n equals d times n plus c. Let's go with the first top row of tiles. So we have 10 tiles, we're adding 1 each time, and the first row has 10 tiles. We need a starting number. So the starting number would be 9. So that gives us a formula a sub n equals n plus 9. Now let's plug in our last row, which is 20. We subtract the 9 from both sides, and n equals 11. For those of you that thought there were 10 from 10 to 20, you're wrong. There's actually 11. Think of it this way. If you have 10 tiles at the top, and you have 20 tiles at the bottom, there would be 10 rows if the first one started with 11 tiles, because we start with 11, then 12, 13, 14, 15, 16, 17, 18, 19, 20. That's like going from 1 to 10. That would be 10 rows. But because it starts at 10 instead of 11, that means there's 11 rows. It's like going from 0 to 10 on a number line instead of from 1 to 10. There are 11 rows. So now we use our formula, n divided by 2. First number, last number, and we have a number for n, which we should put in there, so that's 11. Now this is a little weird because it's an odd number, but fortunately the formula still works even if it's an odd number. So we have 5.5 pairs. It's probably easier if you do this first, because often that will give an even answer so that you don't have to deal with a fraction. So 10 plus 20 is 30. So we have 11 times 30 divided by 2. So that's actually 11 times 15. So now what is 11 times 15? Let's see, 5 times 1. So 5, 6, 1. So it looks like this artwork will require 165 tiles to complete it. This same process can be used if you're counting seats in a theater, bricks in a set of bricks in a staircase, or anything else that is in a pattern of a number of things that increases consistently or decreases consistently, and then you need to add them all up to know how many tickets are in the theater, how many tickets you can sell, etc., that type of thing. So this often shows up, this type of problem shows up in final exams quite often. Something to make sure you can do. Application / story problems, whatever you want to call them.